Hello, physics. This is an interesting question about equilibrium. And the question says that an object of 10,000 Newton is hanging with a rope. Vertically, the rope attached to a 3-meter rod that can rotate through the pivot at point A at its base. This is the point A. This is the rod. It can rotate. And the rope is attached. So this is the rope. This is attached. So this is rope and this is rope. No, this is rod. This is a rod and this is a rope, and that rod can is can rotate. So the question one, draw a free body diagram. So free body diagram we have to find. Okay. And number two is calculate the tension in the rope. So this is a free body diagram. Calculate tension in here, and find the horizontal reaction force exerted at the point A. So the reactive force from here and here, and a vertical reaction at uh, a reaction at A. So vertical reaction. So free body diagram. So this is point A. So this is a reaction force horizontal, reaction force vertical, and this is the tension. This is the tension that is going downward. So this is going downward, tension T1, and this is going up, tension T2. And this is 3-meter rod, and this is the mass, which is a 10,000 Newton. 10,000 Newton, this one. So this is a free body diagram. And this one, T1 and mg are balanced. So T1 is equal to 10,000. This is equation number 1. And T1, if you sum up these forces, so T1 is down, Rx is up, and this component has also that is angle that has a component, this one, this component. So 1, 2, 3 forces. So, and also this Rx, uh, 3, and this is 4, and this is a 5th. So these are the 5 forces. So T1, 1, 2, and 3. So T1 down, Ry up, and this one is down. So now this is this one up, and this one is resultant. So this one. So this is 1, this is 2, this is 3. And Rx and Ry, so this is a 4, and this is 5. These are the components. So as a point A, so this is a point question number 2. This is question number 1, free body diagram. This is question number 2, tension in the rope. Find the horizontal reaction force exerted at the A. Then we have to apply the moment F into R. So all the forces, so into this one. So this is T1 is a force, and it is applied to this one. So you will use a point where more forces are residing. We will use this one, so that moment of Rx and Ry is 0. So all the other forces are applied to this one, rotating this one. So T2 sine theta. So if you say T2 sine theta, this force, so this is the R, and this is this one. It is going toward it is forces up, so it is a counterclockwise. So this one R into F, So R is 3 cos of 60, and F is a T sine of uh, 20, which is I have written as theta. And then T1, T1 is this force. This force is downward, and 3 cos, and it is a clockwise. So it is clockwise, this one clockwise. So T1, 3 cos 60, plus next one is this force, T cos, and this one, and this distance. So which is a sine, 3 sine. So R and this one, this is also counterclockwise. So these are the three forces. So wherever counterclockwise, this is positive. This is clockwise, this is negative. This is positive. So for this one, so we combine this one. So anti-clockwise positive, clockwise negative. So this is the notation. So in this way, so we will combine T2 and rest we will write down, because T1 we have already know that it's 10,000. So if you write down this one, so T2, and T1, T1 is on the other side. So this one is a T1. T1 is 10,000 into 3 cos 60 divided by this plus this. So this plus this. So this, if you calculate, this is equal to 5077. So 5.08 times power 3 Newton. So this is the answer. So I have also explained this one. So this force, T2 sine, so this one, and if it is here, so this is R and into F. So this is this one. Number 2 is T1. T1, if it is here, so it is the same as the 3 cos. So this will be counterclockwise. Number 3 force is this one. So this is this, and distance is this one, this distance. So this distance. So R and this one, it is counterclockwise. So these are the question number 3. Next one is to find Rx and Ry. So T2 when we have found, so equation number 3, T2. So if T2 is known, you can find out Rx. So T2 is equal to 5077 Newton. So Rx is equal to T2 cos 20. So this is equation number 3. Equation number 3, if you put this value, so we have got 4.77 10 power 3 Newton. So this is Rx. Then Ry, equation number 2. Equation number 2 is this one. So Ry, is equal to T1 minus T2 sine of 20. T1 is 10,000. T2 is, we have calculated this one, 5,077 into sine of 20. So that will give us 8.26 10 power 3 Newton. So sum up, T1 10,000, T2 is 5,077, or we can write down 5.08 10 power 3 Newton. Rx is which is equal to 4,077 1, or 4.77 10 power 3 Newton, and Ry is equal to 8,264, or 2,026 10 power 3 Newton. So this is the answer of this question. So this is a slightly complicated, but it is very nice question. So the only point is that you have to know the resolve the forces in a very good manner. So like this one, T2 sine theta is this one, and T1 is this one down, and T2 is minus x-axis. So these are the forces, and then its pivot is this one. So That is the answer for this question.